All right, so today's panel is about OTA updates and fleet management at scale. Very exciting topic. We've got a lot of great questions for our panelists today. But first of all, I'll let our speakers introduce themselves and then we'll get started. So Eric, could you start by introducing yourself?
Yeah, so my name is Eric Johnson. I am a firmware solutions engineer at Memfault. I am one of Noah's coworkers and teammates. We both work on the MCU SDK that we offer through Memfault, and I help our customers integrate our product into their devices. Previously, I have worked at companies like Walgreens Health on their remote patient monitoring team, Athos doing embedded EMG sensing on compression garments for pro and D1 athletes, as well as Acuity Brands and Lexmark. Thanks, Noah.
So thank you, Eric. David, could you introduce yourself?
Yeah, my name is David Shoemaker. I currently work on autopilot at Tesla, but in the past, I've worked at a couple of startups and worked about 6 years at both Apple and Tesla. So I've kind of seen the startup world and the megacorp world both, and worked with OTA in both cases. So I'm excited to talk to you guys today.
Great. And Philip?
Hi, everyone. I'm Philip Johnston. I'm the founder of Embedded Artistry. We do consulting and training for embedded projects. I've been an embedded developer for about 13 years now. And in that time, I've shipped dozens of products over a number of industries. For OTA specifically, I've worked on 2 custom OTA solutions. One of them was actually at a startup with David here. And it's a very common topic that comes up in our consulting projects. So I've seen a lot of different pain points and approaches to the problem.
Awesome. Yeah, nothing worse than a broken OTA solution. All right. So the format of this webinar is going to be similar to the other ones. We've got a couple of group questions and individual questions. And so I'll just kick it off with our first group question. So when is the right time to integrate OTA into your workflow? And how do you evaluate building your own OTA solution versus buying an off-the-shelf one?
Well, I'll kick that off because I have a strong opinion on this. I would say the thing that I see happen most commonly is everybody waits until the very end of the project to integrate OTA, right? They want to get their system working from the functionality perspective, get all their features developed, and then they'll just tack OTA on at the end. Coincidentally, I've also seen OTA delay more ship dates than anything else. I think instead, if you're planning on adding OTA support to your project, it should probably be the first feature that you develop. There's a couple reasons for that. One is just reliability, right? If it's the first thing you develop, you get to maximize the number of iterations you go through with that update process. You can set policies like making sure developers only use OTA updates to send builds to their devices, making sure that your test automation only relies on OTA updates. This way you get a lot of iterations, you get to see corner cases, you get to make sure that when you release your update mechanism, you're not going to be bricking customers' devices in the fields and making so you can't recover them. But also there's a huge number of architectural implications that come from adopting OTA. And if you're waiting till the end of a project to account for those, like that can be a real deal breaker. I guess the basic firmware image strategy is I've just got one application that does everything. Well, with OTA, you're going to need to have a multi-application architecture with multiple boot stages, right? You need a bootloader, you need an application. You're probably going to want a dedicated updater application at some point, right? So you need to structure your system in a way that supports that. You also need to make sure you have enough flash to handle fallback mechanisms. I can't tell you how many times I've seen, the end of the project roll arounds and you want to implement OTA, but there's no, you've got like 10% overhead on your flash storage when what you really need is to fit another full-size firmware image. So that's a hardware redesign effort right there, or you're just not going to have a fallback strategy and risk catastrophic failure, right? So there's a lot of details like that you have to account for up front, and it's easy to do that up front and very, very difficult to fit that in at the end.
I can definitely attest to the importance of starting it early. I've been at companies where we exactly as Philip said, we had to delay our release of a product or installation with a customer because we needed some sort of path to upgrade our devices in place. Also, I think especially when working on a small team, it's so easy to underestimate the amount of work required to implement an OTA solution. And I've certainly been at companies where we started to go down that route. It seems easy in practice, but there is so much complexity just from the back end perspective. Even something as like, well, how can I deliver this in a reliable manner to the devices that are asking for the image? Like setting up a CDN is not easy. And certainly as firmware developers, it's not something that we normally think about. And it's not really in our wheelhouse of expertise, I would say.
That notion of like cross-team implications, right? When you're trying to build an OTA solution, it's not just the device involved, right?
Yeah, it's almost like the device support is the easy piece, which is why we tend to underestimate the complexity of the overall solution, because a lot of the complexity comes in the back-end software that you use to manage your fleet and distribute your updates. And how do I do that in a sensible way that doesn't involve 10,000 devices hitting my server at the exact same instant to try to request a download, and now I've DDoSed myself. There's a lot of implications like that to work through.
Yeah, I think there's when you start updating more devices, you realize quickly there's a bunch of features of your OTA system that you probably didn't imagine early on that you need, but you actually will need. And you realize that very quickly, right away. You're like, we need to be able to send different updates to different sets of devices. Like we have beta customers, we have like non-beta customers, we have QA, we have engineering dog fooding devices, and like we need to somehow be able to send out different updates to different sub fleets basically. And like that's one of those things a lot of people don't think through early on, and then that bites them in the end when they're trying to rush their OTA implementation. But yeah, the big thing I think is you just don't want to be scared to hit that OTA button. You don't want to be worried that you're going to be bricking a bunch of customer devices. You really want to have confidence, and for all the reasons that Philip said, like that's why you need to do it up front. It should be like the first thing in your schedule. I know it's hard to put schedule time, engineering time towards OTA, which is not like a differentiating feature really, although at Tesla it is. But like it's going to be in your schedule before first customer ship. It has to be, so you might as well do it up front and have confidence and have mileage on it, as opposed to delaying it to the very end.
And in terms of go ahead, Philip. Sorry.
Well, I was just going to jump to the build buy part of your question. I think one thing that like you can do to minimize the amount of engineering time you're spending on it is find a solution that exists on the market and works for you. And that can really shorten development times, especially with the fleet side capabilities. That's usually the most expensive part to develop yourself, and where a lot of the complexity lies. From the update side, a lot of times now it's like, oh, I can check the MCU boot box, and maybe my vendor SDK already provides me some basic on-device update mechanism, right? So you could find existing pieces and combine it into a solution much faster than you could, spend 6-12 months developing your own fully comprehensive solution in-house. That makes it a really attractive option. I don't know if you could pay me at this point to do another fully custom OTA solution after having done it a couple times.
Yeah, unless there's like a very extreme problem that you're trying to get around, like a very minimal like bandwidth connection or something like that, right?
But even then, I feel like it would probably be cheaper for you to pay an existing service provider, an NRE, to care about your use case than it would be for you to develop that in-house and then go through all the iterations of proving reliability, right? These existing solutions have gone through so many more iterations than your custom solution is going to be able to catch up to, which is another factor to consider.
Great point.
It's nice to be able to customize the solution to your specific needs, but on the other hand, I think a lot of people, almost everybody I've talked to has oversimplified their custom solution. I've heard like, oh, we just put our firmware in an S3 bucket and all the devices just, do a get to that S3 bucket, or I've heard our code is all Python. The device just does like a git pull, it just pulls it straight from GitHub, stuff like that. And it's, it sounds simple and it sounds like, why would I pay somebody to do this for me? But, as I mentioned, like there's going to be so many features that you need that those oversimplified solutions just don't do. And you're going to end up spending, as Philip said, way more time than you expect actually developing that solution. Which I think everyone would agree. You don't have extra time in your schedule for kind of boilerplate features like that. You need to be focusing on your product features.
Eric, you've seen a couple of different types of devices, especially recently, building on like open source systems like Zephyr. Could you maybe give some color around like how that, how choice of like your platform, your device platform impacts your OTA?
Yeah. So focusing on at least Zephyr, you'll need a few, and this applies to really any system, but at the base of it, you need a bootloader. The bootloader is going to be responsible for actually writing the update into your flash memory on your MCU. The bootloader will do other components, which we'll probably touch on later, like validating the image and things like that. But its primary responsibility is to essentially take an image that's on the device and copy it into Flash, into the Flash space that's going to be the partition that you boot from. And the concept of partitions essentially just means you're dividing your Flash into two different spaces, and one space you'll be running your application from, and the other space you're going to use to store a new update. The other kind of component of this is you could choose to not have those two partitions, but you won't have any fallback mechanism in that case. If an update does need to be replaced, you'll need to, you essentially need to rely on always having the capability of updating your application. There's no fallback. There's no breaking case of glass in an error situation. Once you have the bootloader that can manage these image partition, you do need a way for your application to tell the bootloader, hey, I've downloaded a new image, go ahead and apply it. So, in the case of Zephyr, Zephyr uses MCU boot generally in this case. And then there's a component that you build into your application called MCU manager in general. And this has some hooks that you can implement to alert the bootloader it's time to apply the update next time we boot. And then kind of the final piece is you need some sort of transport component that can receive the image and pass it, into the code that's writing it to your Flash. In the case of Zephyr, around BLE, that's usually SMP. And so that's the protocol that like your phone app can talk to, or your gateway device, to transfer the image over BLE. And there are other components that are supported within Zephyr, like Update Hub, or we have an OTA client there. But those are kind of the primary building blocks that are needed for OTA, at least on the device.
Right. And when you're making decisions about like your system, you say you're like early days in a product's design lifecycle, and you're looking at systems like Zephyr or other platforms that provide like a lot of these comprehensive solutions, like what things do you think about when you're evaluating what choices to make essentially at that stage?
Yeah. I always take a look at like what transport is supported. Am I going to have to write a lot of code to just vary the data, between the end device and a gateway, or if it's directly internet connected? What sort of, another feature that's kind of part of MCU manager is this concept of like confirming an image. So like once you have booted a new image, you need a way to validate that, okay, I am not going to brick the device if I stick with this application version. So definitely looking for features where the bootloader can know that this image is valid and confirmed. That's kind of a terminology used with MCU manager. It is a really solid, because we, in the past, it's always easy to push images, but it's harder to know that they're actually valid, and you want to continue using them, and you don't need to fall back in that case.
We'll talk more later about security stuff, but just briefly, what sort of security like checkboxes do systems like that satisfy?
Definitely like the kind of first stage is image validation, and like whether or not the image that you've received was, built by your OTA system rather than a malicious actor. And so that's where the concept of signing comes into place. You use a key system to sign the image so that you know that it came from you and not someone else. And sort of a separate topic is, whether or not you encrypt your images. So that's another feature that is definitely important for your bootloader to have, because it should be the one decrypting those images if they are encrypted in the first place.
Got it. And how would you decide whether to encrypt an OT image?
I think you kind of have to look at your threat model and what's important to you. Do you have a lot of proprietary code that is really, maybe contains trade secrets or things that you really want to protect? Or, is it less important if someone were to obtain an image and do some analysis on it? Those kind of things. Also, if your image is containing, some sort of other secret, maybe an API key, then encrypting that image becomes much more important.
Nice. Yeah, that makes sense. I guess some other impacts that could occur at that when you're making decisions about your OTA scheme certainly could impact the hardware. Could you talk a little bit about that?
Yeah, you might want all those security operations we're talking about are expensive for your CPU. So you might want hardware that has dedicated encryption blocks with it. And then you want to make sure that your RTOS or whatever supporting software you use has support for that hardware. It's a pain to write drivers for those components. And in general, I'd say the vendors are the experts there. And they really should be the ones driving that software development. And with all those features that we've mentioned, comes increase in space. So it's you do need to budget more flash and RAM usage. And I'd say that's why it's increasingly important to always have some amount of headroom or tolerance on how much RAM you have, because you're going to want to add new things, and each addition increases that usage.
Right. Great. Well, thanks a lot, Eric. That was very nice overview of OTA systems. Next up, I'm going to switch to Phil. So your question is can sort of continue on the security side. Security integrity, how do we manage that? Avoiding brick devices, AB, et cetera. What are your thoughts around that?
So like Eric said, I really think code signing is sort of the foundational aspect of having a secure update, right? If you're worried about security in your updates, generally you care about two different things, I think. One is the integrity of the image. How do I know that what I received is what I was supposed to receive, that it wasn't, corrupted in transfer either due to a communication error or somebody tampering with the image? Normally we would use a checksum for something like that, but there's nothing that stops an attacker from sending you an image with a valid checksum that's not supposed to be installed on your system, right? So you need another layer there. That's where the code signing comes in. So you'd have your CI server or whatever you use to produce releases, it's going to generate a hash of your binary, and it's going to encrypt that binary with your company's private key. Your devices are going to, check the signature using the public key, which is stored somehow, whether it's baked in the bootloader or more ideally it's stored in some kind of, assistant cryptographic device that's tamper resistant. And if the signature doesn't match, ideally you're going to reject that at the update stage. But you could also just, move now toward a secure boot strategy where I'm only going to boot images that actually have a valid signature that my bootloader can verify. The challenge here is this whole scheme depends on you protecting your private key and not having it leak out. So key management is now something that you have to take very seriously. It's really frustrating sometimes because it's inconvenient to keep private keys safe and use them to generate signed builds, right? I think we've all been annoyed in the past if we've dealt with signed images of like just how much of a struggle it can be sometimes to do such a simple task like load a new image onto a device for debugging purposes. But you have to take it seriously, because if that key leaks, then anybody can create an image that would be valid for your system. You need to be able to deal with key rotations. Like if your key leaks for some reason, you need to be able to swap that out on the device in a secure way. Code signing is essential for secure boot, but it's not like you can't just have a bootloader that checks signatures and call that a day, right? You need to make sure that nobody's swapped out your bootloader on local flash to just take out signature verification altogether. So usually you would have to incorporate some other hardware element that gets you a earlier root of trust that allows you to verify your bootloader is valid. I'm actually going to give a different opinion on encrypting images. I don't really think that encrypting a whole image itself is very beneficial. Part of it is a performance reason. You usually can't execute an encrypted image in Flash. So you have to, if you're going to go that route, you have to make sure you have a lot of RAM so you can decrypt the image from Flash into RAM and run it all out of RAM. Maybe there are some advanced MCUs that allow decrypted execution, but that would just be really hard for me to imagine how that would work from a hardware perspective. I think like internally, encrypting secrets is definitely a more viable option because you can do something like that at runtime. Or again, using some of these like offboard secure storage items to where, the program doesn't actually have access to the secret itself. That's stored in some other device that's set up at the factory or through some advanced, interaction that makes it a little more tamper resistant. The other part was fallbacks, right? So I think, if we're thinking about when does security and integrity really matter, like just consider a medical device, right? We want to make sure the right image is getting on there, and then we can never have an update fail, right? Because we can't have a broken medical device that seems like it might be operational. The usual strategy here is you want your updates to be atomic, if at all possible, right? So either my update completely succeeds or it doesn't happen at all, right? We don't want to leave our device in some middle ground state. That's really the difficult part. We've mentioned the dual partition strategy multiple times so far, right? So that's the most common. I'm going to receive a new image. I'm going to load it into the partition I'm not using. If that process succeeds, I'm going to have my bootloader boot out of that one. If anything goes wrong, I can always, switch back to the previous partition to a known working image. A lot of times we get to the end of the project and we didn't allocate enough flash storage for that. So another thing I've done on more resource constrained systems is you just have a dedicated fallback image, right? So it's not as resilient from the perspective of I always have a working system, but you could say you just have a minimal application. All it knows how to do is bring up the communication stack, talk to the server, report that there was a problem, and request a good build. Whether that, and you have to manage that interaction, whether you try the same one again, whether you go to a previous. But in this case, you can usually get away with, I have a fixed size overhead. I don't generally have to update my recovery image ever. I don't need twice the storage space for what I expect the application to use. I can just have this one fixed size image that at the very least, if something goes wrong, always knows how to phone home and try to get it to a good state again.
That's a great strategy. We called it factory image at Fitbit, where the user could always, if the device really gets into a sad state, always push it back into that, out of box state, which I think is a great strategy. Awesome. Thanks very much, Phil. That was very illuminating. All right, David, so you're up. So your individual question is about distributed systems. So how do you deploy a firmware update to a system that has like many components, very complicated, what kind of strategies do you use there?
Yeah, just as Phil just mentioned, you want your update to be atomic, right? And so even if you're updating multiple components, you want it either to fully apply or not apply at all. You don't want to have some components updated and some not. And it seems like most devices these days do have like this distributed topology, whether you just have like a Bluetooth module you need to update the firmware on, or PCI USB controller, something like that. Like there's always some little component that needs a firmware update, and you want to make sure that first of all that you that you add an affordance for that, right? From in your OTA system, you want to be able to update all of those components. You don't want to leave any of them on an island, and never to be updated again. And so I think the base level of functionality you need to get to is kind of a whole system image, or bundle, I guess you could say, where you include like the main firmware along with all of these like component firmware updates in one image, and then when that image lands on the device, then you have to build a really reliable way to have. Usually you have like one kind of primary component that updates the others, and you need to make sure that it goes through and updates one at a time, verifies that each update applied successfully, go through this whole process that we've been talking about of potentially rolling it back if it did not, and do that for each component on the system. And then only after everything updated successfully does the main component then kind of update itself, and follow the same practices of having a fallback rollback mechanism in place for that as well. And it adds a lot of complexity to the system, because if you have to roll back the third component that you've updated, you then have to go back and roll back the others as well. And so you have to, was another reason to implement this early on, because you have to have this, this is going to add a lot more budget to RAM, flash, everything on your system, hardware and software, to be able to pull this off. The other thing I will say is that a lot of people try to, once you have that full system bundle working, a lot of people then try to update individual components, like, in isolation. Like, say they only want to update their Bluetooth module, like they don't want to ship a full update to the device just for that. And I understand the desire for kind of optimization there. At the same time, your compatibility matrix and your testing matrix just blow up, like crazy once you start doing that, right? I don't know, maybe you guys all write perfect code, but like, I'm not happy shipping something that hasn't been tested, right? If I haven't tested this exact firmware, with this exact Bluetooth module update, like I'm not going to trust that that's just going to work in the field, right? And so how are you going to test every combination of all these things? It's basically becomes an impossibility. So if at all possible, I highly recommend just avoiding that and sticking with the full system update at all times. I mentioned I'd worked at I've worked at Tesla and Apple, and like, these guys, obviously it cost them a lot of money to send out billions of software updates, and yet still they don't tend to mess with stuff like that of like, trying to update an individual component. They keep it simple, right? Because they want it to be reliable. They want it to work. That's the top priority here, is not to brick any devices and not to leave them in a bad state. And so, yeah, I think if you're thinking that you really need to be able to update individual components of your distributed architecture, you just think really hard if you actually need that, or if you can get by without it. Yeah, and then when it comes to verification and security, as we've been talking about, it just gets that much more difficult when you have a bunch of components that you need to verify, and they all need to work together. And I was going to mention one strategy. If you do update individual components, one strategy I've seen work is you have to have a manifest file that says, what is the minimum version of the other components that I require to run, right? And this kind of requires that you adopt like a monotonically increasing integer version scheme, basically, because each component will have to say, like, I need these other components to be at least at this version, otherwise compatibility cannot be guaranteed. And then what you do is, before you apply the update, you kind of make sure that all of those constraints are satisfied, basically, and that nobody's going to be, none of those preconditions are going to be broken. None of those invariants are going to be false if you were to apply this update. And that's one way that you can manage, compatibility. But it still is going to be very complex if you go down that road.
Nice. I couldn't agree more. Keep it simple for these critical components.
Yeah, I really want to go ahead. I just really want to emphasize that I've never seen a multiple version dependency matrix work out in practice. I have heard of so many teams wanting to try this, but I've never seen anyone actually stick with it, because it might work while you're in development and you're kind of always incrementing everything. But once you have devices in the field, then you start having distributions of versions, right? Not every device in the field is going to be on the exact same version. So now your compatibility matrix and the amount of testing you have to do, it just grows exponentially, and you just can't keep up with it. So I've seen so many teams like try that strategy and then just completely abandon it because it's not something that they can sustain or justify investing the like amount of QA and testing into that it requires.
Yeah, couldn't agree more. One thing I wanted to add on that component, like your distributed system devices, is it can have implications to your hardware too. If you want like a fallback or a failover mechanism where you can like, you know, toggle a pin to trick some devices to go into bootloader or something like that. And some SoCs will even have like a built-in ROM bootloader that you can leverage. So instead of writing your own bootloader, like take advantage of what already resides on the chip. And so those can be pretty good strategies. So it's always good to explore the margins of what your hardware can do. Awesome. Thank you so much, David. That was a very good discussion there. All right. So our next question is going to be for the group. So this one is on, it's a doozy. So this is the fleet management and deployment controls question. So how do you perform the OTA execution from like a fleet management or ops perspective? So how do you do rollbacks? How do you like selectively update groups, that sort of thing?
I mean, the first thing I would say is the prerequisite for this is you have some sort of feedback loop from your devices, right? So you need to have some sort of like analytics in place, essentially some sort of telemetry. And if you don't have a way of measuring your device's health in the field, you're just not going to be able to do this. So that's another component you're going to need to build is, hopefully you're collecting, crash dumps, and hopefully you're collecting stats on how often these errors take place in the field, and that will allow you to do kind of the staged rollout, where you send out an update to 5% of your devices, and then you wait for that telemetry to roll in, right? And you see how it looks as compared to previous builds, and that will inform, if you can then move on to a larger percentage of your fleet.
Yeah, I think staged rollouts are like a must-have capability. I don't think it's smart to have OTA update capabilities at all if you can't do a staged rollout, because you're just going to DDoS yourself. Every device is going to check in all at once, and you really run the risk of catastrophic failure. Of you release a bad update that suddenly breaks all the devices in the field that try to apply that update, and you have no way of halting that process once you see that it's happening. It's too late when your customers are calling you on the phone or filing ticket requests, right? You've already done the damage. And so a staged rollout really is like you're hedging against the fact that you could brick a bunch of systems by testing it out first with, a small population before you decide to subject everyone to it.
A similar control that I've found very useful in that is controlling when updates get applied. So for instance, a previous company, we had a customer installing device, and we had staff on site to set everything up and like run through their first usage with this device. And it was always nice. It was especially nice to not have, our staff that are on site have to worry about, oh no, the device is going to be inoperable because it's receiving, 12 updates because it was built 3 months ago and we've released that many updates since then, and now we're all just standing around waiting for the device to finish updating. And really just having the ability to have fine-grained control as to which devices are going to update now rather than they're going to hold off, I think is really important and extremely useful when you run into this scenario.
Yeah, a couple of details you might want to think through when it comes to staged rollouts is you, as opposed to just like a random sample of like 5% of your customers, you may want to have like an early access program group that's like always like your go-to, or, early adopters, basically. These are people that you trust, people that can give you feedback. But also another detail you might want to think about is have them agree to a different privacy policy than the rest of your customers, because that could allow you to collect more data from that group, right? Which will give you more information about how the new build is performing before you roll it out to your customers at large.
And I think all this touches on, something, or we all keep touching on this capability, but we haven't explicitly called it out, of like binning devices into cohorts, right? I mean, you could implement staged rollouts in that way, especially if you're doing something like first deploying rollouts to an early adopter program. I mean, it's essential for, maybe you have 2 customer sites and you want to have different builds for each customer site. Well, you need to be able to group those devices into separate groups so you don't send the wrong update to the wrong group. And you still want to be able to do a staged rollout even within a group potentially, because again, you can't just, you have to control those update processes differently. So even within a cohort, I might want to make sure that I'm not going to brick all of one customer's devices, right? Rather than I'm just going to try to incrementally roll out to everybody regardless of their group.
Yeah, when it comes to fleet management like that, in the different cohorts, you also want to make sure that that is something that's accessible to like non-engineers within the company, I would say. Typically by the time that we're doing a staged rollout or a rollout at all, the engineers have already been moved on to like the next version for a while at this point. They're not really involved and should not be involved in like kind of handholding and, controlling the deployment. And so to have a system that's usable, has some sort of user interface that allows people who are maybe less technical to move devices between fleets and like, basically provision these staged rollouts and is very helpful.
And once you have all this in place, I really think that like, if I can collect data from my device, crash dumps, metrics, things like that, and I have a staged rollout capability, I want to start doing something like what Memfault does, where I could automatically start collecting issues that are coming in from the field, and I could use that as a gate to automatically halt a rollout process, or even automatically perform a rollback because I just decide just flat out that this build doesn't meet our specific quality gates. Something like that makes it a lot more bomb proof, I guess, in that you have a check. You don't have to have somebody there watching constantly the dashboard to determine whether or not something is okay or not, right? You can have automation in place to safeguard you and stop an issue as early as you can really detect it.
Awesome. That's a really great point, Philip. Like the more the computers can do for us, the less we have to worry. In terms of like, when you do get these stuck devices or stranded devices, like what are the strategies around that? I know this is a tough question, but
RMA, baby, just gotta send it in. Sometimes too, I think like you can, if your customers are amenable to this, you could always still have like a USB recovery tool. You could, support some kind of DFU restore mechanism, right? You can generally, your iPhone generally updates over the air, but if anything goes wrong, you can plug it into a computer and reflash an image. So I think something like that as an escape hatch is essential. It doesn't work for every device, right? If you brick your scientific buoy in the middle of the ocean, I mean, what are you going to do other than get on a boat and try to find it, right? Or just leave it there, which isn't ideal either. So it depends on what your use case is and what your customers are amenable to doing.
that certainly requires having that instrumentation to notify you that, okay, we lost this device, we need to take some action, assuming the customer isn't already calling you.
Right. Something else that comes to mind too, like we talked about fallback mechanisms, I don't know if it's really common, but something that I run into a lot is like you deploy an update and then the device appears stuck or gone. And what's actually happening is it's just repeatedly crashing before it can get to main or do some other meaningful action, like check into the system. So you can even, put some safeguards in your device, like you have a crash counter that lives in a section of RAM that doesn't get erased during reset or doesn't get initialized until a certain point in your program. That way you could have your bootloader detect like, oh, hey, I keep resetting due to a crash and I keep seeing the crash counter go up. I'm going to now go to my fallback strategy automatically to try to get the device back to a working state. So there are some, depending on what the exact failure mode is, there are some methods you can take on the device to mitigate that too.
Yeah, probably you should have mentioned that earlier, Philip, because literally every good OTA solution I've seen includes that, like a crash counter. That's a must-have, I think.
And there's some satisfaction in testing that too, where you get to generate the junk image and shove it out on the device. Watch them hopefully come back. Yeah. Awesome. Great. That was really good, guys. And any other things we wanted to cover on the sort of fleet management side? I think that was pretty comprehensive.
I guess you do need a way. We talk about rollbacks a lot. You do need a way to instruct your devices to roll back, whether that's, a specific command to, restore the previous partition, or maybe you might need the ability to actually put an old version on the system. I've seen a lot of systems restrict, like, we will never downgrade, right? We can only upgrade our version to an increasing number. Maybe that restriction doesn't work out if you want to support some kind of rollback operation. So that is something to think about and to incorporate in your fleet management. Is I want to explicitly say this version is no good, go back to an old one.
Yeah, one other detail I mentioned, making the fleet management accessible to like everyone within the company, or like maybe non-technical users. You may also want to make it accessible in some limited fashion to customer service, right? Like if you have a customer on the phone, they might want to be able to send a specific build to this one customer, things like that. So think through some of the customer service use cases and make sure your fleet management and your OTA will work for those use cases.
That's a great idea. I'm going to take that one, Shu.
It's yours for free.
Amazing. Love it, guys. Okay, so now we're going to do a few rapid fire questions for you guys. So get ready. Starting with you, Eric, you're in the hot seat. So the question for you is, what's the scariest firmware update you've been a part of?
Anything that touches the data transport on the device, changing protocols, or I had a particularly scary one. We were updating the Wi-Fi configuration on the devices, and so if we got that wrong, then now they're no longer connected, and we can't actually push rollback or really talk to the devices at all. Anything around that needs like increase in testing, and just is particularly nerve-wracking, I would say.
Nice. Yeah, that sounds stressful. All right. Next one for you, Philip. What's an unpopular opinion you hold around OTA and fleet management? You knew this was coming.
I don't, but I do have an unpopular opinion. Okay. I think that OTA updates are great for development teams, right? It de-risks a whole lot of things. It gives you more breathing room to release your product when it's not fully ready. As a customer, I absolutely hate the fact that you have OTA updates and you use it for that purpose. Because for me, it's like when I'm using my device, it's always at the worst time that it updates. Like Eric mentioned, oh, we're trying to do something, but now we're standing here, waiting on this OTA update to finish. For my Kindle, for whatever reason, this is always the case, right? They collect all this data on me. They know when I read, but it's always when I start to read that I go through this update process. So that annoys me. I hate that I can't roll back my software to a previous version, right? I have a tablet that OTA updated to a new version, terribly buggy. I'm stuck on it, So I get the developer dream, but I really think that we don't pay enough attention to the user's perspective and consider that carefully enough. Because I'd really rather you just get it right the first time and never update your device, is how I feel as the embedded device user.
Wouldn't that be nice? Awesome. Thank you, Philip. All right. And for you, David, we touched on this a little bit, but some thoughts around, like, is there merit on defining a section of your firmware that is never updated?
That's a great question. I think one thing we didn't touch on is, are there sections of your firmware that should be updated, but that you forget to build update capability is a related question. Like, for example, the bootloader. I think a lot of people do not plan on updating the bootloader. And so I guess some people's opinion might be that is a section of the firmware that should never be updated because it's just too risky. On the other hand, I think planning for something that's never going to be updated is never a good idea, because it's always going to need updates at some point. So yeah, I mean, personally, I would say make everything updatable, and never assume that, like, oh, as Phil said, we're gonna get this right the first time and it's never going to change. I think just assume that everything's going to need updating in the future.
Awesome. Yeah, that's a great bit of wisdom there. Thank you, David. All right, so that covers our primary topics that we wanted to cover today. We have a lot of great questions from everyone who's in the audience, so we're going to get to those in one moment. But before we do that, I'm going to quickly Sorry, let me just shift the screen here. Okay. All right. Yeah, so questions from the audience. The first one is, Philip, you talked about this a little bit, actually, the fallback mechanisms. Could you describe in a little bit of detail, like how those strategies typically work on devices implementing like an A/B scheme?
Yeah, so, I guess in terms of how do you trigger the fallback, you might have some metrics on whether or not your update succeeded at all. Maybe you have a flash error or some other, error that you detect during the process of writing that image out to the flash storage. Well, then you could just say that you could mark that section as bad. You're not going to try to transition. That's one way of doing it. Or, you're going to fall back. Signature verification during boot, right? If I can't verify the signature, I'm going to try to fall back to the previous section. Crash loop detection is another automated way to figure out that you need to fall back. I think those are probably the three cases that I can think of off the top of my head for like how we might figure out when we want to fall back from our current partition to a previous one. You do have there is always the potential for what do you do if both of your partitions are bad? That's definitely another layer of complexity, and perhaps why you want to have that factory image that you can always get back to.
Nice. Yeah, that's a great answer. We have another question here. Actually, a few questions that folks have been asking around. How do you do the key management for like signed images? And maybe David or Eric, if you've had experience with that.
I mean, one thing I will say is that you need to, Philip already mentioned this, but you need to build in the ability to rotate the keys, right? That has to be there. And then the other thing is a lot of companies will try to keep their private keys in an air gap, situation where, it's literally just offline. It's on a computer that's not in any way connected to any network, right?
Mm-hmm.
Not everybody does this, but that's the best way to, I'm not going to say ensure, but at least increase the likelihood that your keys are going to stay safe. And what that means is that at least for customer builds, they're signed, they have to go through this kind of manual signing process where somebody uses like a USB stick or something, which of course can also be compromised, but is less likely to be, to take the build over for signing before sending it out to customers.
Having separate keys for development and production, I think, is essential because it enables the developers to work efficiently without going through the common failure mode of I'm sharing my private keys in a dumb way to make my work easier, right? Don't keep it in your GitHub repo. Don't keep it on the network. I think another strategy, if you're not doing the air gapped approach, would be to just store the private keys on whatever your CI solution is. And maybe that is a dedicated machine, and you have to really restrict access to one, who can edit the private keys and view them, and two, who can access that machine. There's, if you're using GitHub or GitLab or Circle CI, they have secret management routines that can restrict access and make sure that you're not publicly displaying those. Although, in the unfortunate case of the recent Circle CI incident, that's not a guarantee. Everybody's secrets were exposed, and now we all had to go through this, rotation process because you're at risk, right? So it can be hard even if you're using a specific solution that's dedicated to managing those secrets.
Thoughts on per device keying? That's something that we get asked pretty frequently.
It's even harder than you think to implement and manage. There is an incredible amount of management tied into choosing that architecture. I personally have not used it in the past. I understand that there certainly are scenarios where it is required, and I think knowing that it requires so much work, it's not as simple as we're just going to store a key per device.
Yeah, you have to manage those. You have to be able to rotate individual device keys, ideally, or you just accept that one of your devices is always compromised, which, if you're going through the efforts of per device keys, I don't think that's an acceptable answer. But that is a huge amount of overhead to do that.
Yeah, it also has implications on the back end too. Like any kind of CDN or caching is going to be out the window if you have per device keys. Generally, you're going to want to do signatures like on the fly because there's no way you're going to generate, signed builds for all of your devices and store those. So you got to think through that as well. The closest thing to a medical device I've ever worked on is the Apple Watch. So I'm not really an expert when it comes to like some medical device requirements. I'm sure that there are cases where it's absolutely required, but if you can avoid it, you should.
Nice. We have sort of a couple of questions that are related, so I'll ask them together. One is, what are the best strategies for ensuring that your OTA update process consumes as little power as possible on the device? That's one. And then the second one is about reducing size of OTA payloads. But let's start with the power consumption one first.
I think an important thing is to limit when your device is checking if there's an update, or if possible to always push those notifications down to the device, because your backend is going to know when there's a release versus your device operating in the field having to pull them. The fewer messages that are sent back and forth, the better. And yeah, really reducing that frequency. I think if your device has to pull, which is very common, it's certainly not a bad strategy. I think reducing that to your minimum required frequency is really key there.
There's a great article on the Interrupt blog about Delta firmware updates that I think is going to, cover this too. But that's one way to reduce the amount of power consumed, is to reduce the size of the payload. Like with other update optimization strategies, though, it really is an additional layer of complexity and risk that you're taking on. You need to generate Delta updates for all of the different combinations in the field that exist, and you have to maintain those for every version, and that can definitely be quite difficult. Or you have to go through an incremental update strategy, which doesn't necessarily jive with saving power. If I want to, if I'm going to apply 10 Delta updates, that's not necessarily lower power than applying a full firmware update, right? So you need to make sure for that reason that you can jump from one version to another specifically. Although, there's always incompatibilities where we might have to insert an intermediate step where we limit, the logic on the back end. Some version is known to have to update to a specific version and then jump to another, right? You have to consider these kinds of complexities when doing Delta updates, but you really reduce your communication bandwidth because you're only sending the binary bits that changed, and you really reduce your power consumption because you only have to rewrite specific sections. Your radio can be on a shorter amount of time, things like that. Probably speeding up your clocks to get the update done as fast as possible is another good strategy, right? To optimize power consumption, you just want that to happen as fast as you possibly can.
Yeah, I would once again caution against like premature optimization when it comes to Delta updates, and also point to my current and previous employers of like Apple and Tesla, where our updates are huge, like multi-gigabyte updates, and yet they don't mess with Delta updates just because of the complexities that Philip mentioned. I think one strategy that can work for like reducing the size of your update in general is I think you can maybe split out like a full system update versus kind of like an overlay update, if you will. Especially if you have like a Linux system where, maybe you don't want to update the kernel and, all the, user space libraries and everything. You just want to update your application layer, essentially. Like, I think that's something that you can, that's a strategy you can employ to reduce the size of the update. Another strategy I would employ for like reducing power usage in general, and also a lot of other features that come with this, is build your OTA process on the device to be flexible and to be basically to allow the update itself to kind of control that process to some degree. Like one strategy I've seen work is that the update package itself includes like a pre-update script or a post-update script or something like that, and the updater on the device just simply runs those scripts. That's very generic, right? And it allows you to, after the fact, really modify the update process, right? And so that could help if you're working on power optimization during update. That's something that maybe you don't have to build it up front in the updater. You can actually build those optimizations into the update itself, as long as the updater is generic enough to run code that comes with the update, basically.
Yeah, that's a great strategy to like sort of rescue some devices that may need some extra care and through that update process. Great. So we're coming up on the top of the hour. I'm just going to real quick share some background on our speakers, and then we'll do a few more questions before we wrap up. Okay. So yeah, first of all, thank you so much for the speakers that we had today. I really appreciate you all joining us. And you can see there's some contact information here for the folks on the panel. Also, it's David's birthday, so happy birthday, David. And yeah, please get in touch. We'll be sending out an email after the panel that'll include some various contact information, links to the Interrupt Slack. So come in and join us there. We're all in there, and as well as a recording of the video. And then that if you do have a few minutes to enter that the survey at the end of the talking about the panel, then that would be great. It helps us sort of improve these as we go. All right, so we do have a few more questions that were pretty interesting. So one is talking about what is sometimes a very scary time, but the person was asking, what do you consider when you want to update a bootloader in the field?
How much testing can you do? I think, hammering that on as many devices as possible in various combinations of bootloader versions, I think is essential, because, you probably don't have a fallback bootloader on your device. So if that fails, you're kind of hosed. I think there's whatever your chosen method of hope, prayer, sacrifice to the gods, it's you need a little bit of that to get some goodwill on your side. But I think, yeah, just thorough testing. How many iterations can you put it through until you're confident that you're not going to break devices? I don't know of another shortcut than that.
Yeah, I think just to make it a little more clear on the thorough testing, like it should be automated testing. You should have like a rack of devices that are just 24/7. They're just updating. That's all they do is just like update, and then track failure rates, and if it's anything non-zero, then don't send out that bootloader update.
Nice. Thank you. We've got another one. We touched on it a little bit, but if we have like very old devices that haven't checked in a while and they come online and it can't perform, it can't perform like an update to the latest. What kind of things do you put in place to sort of handle those situations?
Yeah, definitely happens. Go ahead, Eric.
I was going to say, yeah, it's definitely happened to me. And I think the important part is to have a mechanism in your OTA service where it forces the device to pass through the version that it needs to get to its destination, which is harder. It's more difficult. Like, this is, I think, why it's important to evaluate all the solutions out there for you. And this is harder to implement yourself than you would think. Kind of having that rules engine around, I have this current version, I'm this software type, I'm this hardware revision or type. What update do I need now? Trying to plan for all that logic ahead of time is difficult, and a lot of the OTA solutions out there will handle that for you. It's especially important when you're a small team. It's not something I would say that's important for you to spend time on.
I think also you need to really have the capability of knowing what version's on a device. This is another reason to like feedback loop from the device is essential, because you can't gauge whether or not you're going to run into this problem and put in the steps to correct it if you don't know what version's in the field. So you need to get that version from each device in some way and be able to respond appropriately with whatever update your payload you're sending. And, like Eric said, I would definitely pay for that solution rather than develop it myself. But I also think like, you need to be monitoring your fleet to know what versions exist, and test the various update combinations to even find these issues in the first place, right? I think if you find out that you can't do an update jump from one version to another, that's a pretty advanced thing to learn, right? A lot of teams don't learn that until they brick devices. You have to be preemptively looking at the distribution of versions in your field and then actually doing QA on every release to flash a device with that version and then make sure OTA updates succeed. And that can be complicated, but that's what you have to do to figure out that kind of thing.
We have one I think is intended for you, David, asking about what Tesla being a very like sophisticated OTA device. There's a lot of components, including safety critical components, being running in those systems. What is your biggest concern or biggest problem that you face during OTA of these devices, if you can talk about it?
I am not super intimately knowledgeable about Tesla's OTA system. I do know that, as mentioned in the question, there are a ton of microcontrollers that get updated across the car, right? Like we talked about distributed architectures, and a vehicle is probably one of the most complex examples you'll see of that. Yeah, I think in terms of safety critical components, of which there are many on the car, we're very cautious about updating those, and those frequently involve working with third-party vendors as well, which is something we haven't really touched on in this discussion. But you have to work closely with your partners to make sure that the updates are safe. Those vendors typically, they have a bunch of different customers, and a lot of times they're doing specific NRE for other customers, and then they end up giving that the result to you just because it gets rolled into their main line. And so you have to be cautious of things like that, like where what has changed here since the last time we sent it out, and it just requires enormous amount of testing and validation.
Yeah, and I think we just touch on the fail safety aspect again, right? You need to make sure that you can fail to a safe state and recover from that, and you have to really prove that out.
And that applies equally to consumer grade devices as well as these safety critical ones, although the penalties are different.
Absolutely.
One thing that I just thought of as a particularly scary update was we didn't have any logic in place around whether or not our device had enough battery to apply an update. So I think it's important to only start updates when your device is in a good state to take one. Because particularly, if you've got low battery and it's about to turn on its radio and start running that for a while, you can get yourself into a really, really just poor experience if the device is now out of battery and the consumer has to deal with that, and you can get into loops essentially where the device has just enough power to get the update but can't actually apply it.
I'm so glad you brought that up, because that's something I've dealt with on pretty much every battery powered project I've worked on. And for some reason, it's not something that we preemptively think about. It's just like, why does my device keep browning out when I'm trying to do an update, or something like that will happen to trigger it. That's a great point.
One more, I think this will be the last one we'll have time for today. So this question is asking about if you have a wireless device that has like signal strength issues, so it maybe like is dropping packets. How do you deal with that from an OTA perspective?
I think ensuring that your updates are at least atomic will give you a reliability around that, but it doesn't make the process itself any easier.
Yeah, I would definitely put in some kind of exponential back off in trying your updates, so that you're not going to do something like completely drain your device's battery attempting to get updates that are continually failing. If you're having trouble receiving data and that's a repeated thing, you should definitely back off and wait until, hopefully the device is in a different place, or conditions have changed, or, something has changed to make that actually succeed, rather than dumbly repeating until you're just dead in the water.
Yeah, ideally, you also, if you have the resources for this, you separate like the download from the applying of the update, right? And as we've talked about, you're going to want to verify the package as a whole before you apply it ideally anyway. And so that will really help in these situations. Obviously, like if you're trickling the download to the device over a period of days, you know, that can be more bearable as long as it's just kind of a background process that's staging the update as opposed to, you know, the separate step of applying the update.
But difficult to do because, you know, a lot of our systems don't have enough RAM to hold a full memory, especially if you're working on a microcontroller. Embedded Linux, definitely a lot easier to pull that off.
I think the other, using a protocol that allows like that sort of that many errors to occur without, let's say, like resetting the connection, is really important there. So I think that can make, like, for instance, HTTP a challenge because you're relying on TCP as the underlying layer there. So there's a lot of back and forth that has to happen in order for the connection to be maintained. Yeah.
Speaking of HTTP, I triggered something which is sure on my mind, which is that you want to build in like resumption capabilities here, right? Because if you're having downloads fail because of a flaky connection, the last thing you want to do is have to restart it every time. You know, you want to be able to resume that download. So if you only get 8% of the download and then the connection gets dropped, just make sure that you have whatever protocol you're using, whatever your backend is, make sure that you can resume that download from the 8% and move on, as opposed to like starting back at 0. Because otherwise it's just never going to get there.
Mm-hmm.
Especially with these low bandwidth devices, like if there's Zigbee or something, you will just never OTA successfully if you have to restart every time. Yeah. Great. Well, thank you guys very much for entertaining all those questions today. I think it was a lot of fun for me, and I hope our attendees got a lot out of it as well. So yeah, thank you, Philip, David, and Eric for taking the time today.